Hey everybody, it's time to get started here. I think, yep, we're on the ultra low latency. We love it. Let's get started here in just a second. We're going to pull up everything seems, there we go. I do all the changes with my lights. It looks pretty good. I think we're good today. So we're going to pull up some 474. We got Mubot here. Mubot is in the chat, giving out points as per usual. So let me pull up I think the email we're getting sent right here. And let me take a look. We're going to try to replicate something here. And I think, no, that's not the email right there. Let's see here. We're going to get the email. And let's see. I think Chloe's sending it now. Brian, I got it. Do you know what Oh, I know Dark Souls all the time. Demon Souls, Dark Souls. Demon Souls came out on the PS4, the remake of it. And I know Dark Souls. I played tons of Dark Souls. I was actually watching a Dark Souls video today. Meryl says, "Hey Brian, whenever you get a chance, can you look over the second job question on chapter 16?" You bet. We're gonna do 474 to start, and I know Dan and Meryl have tons of 201 questions. We're definitely gonna do a ton of 201. I need to play Bloodborne. Yeah, I don't have PS. I don't have later than PS2. Okay, I have a PS3. I forgot, but I've never hooked it up. I think no wait. Let's see here. We're waiting. Let's see here. So many questions. I'm getting a bunch of email, but maybe wait, did she send it? She hasn't sent it in the Discord yet. Okay. We're going to wait here a moment. I think Chloe, I sent the email. Awesome, Chloe. Thank you so much, Chloe. We're going to replicate this error right here. I'm going to try not to show the full assignment. Which line of code are you getting this on, Chloe? Whenever my email updates, which line of code is giving you this? Here we go. Here we go. Thank you so much, Chloe. Okay, we've got Chloe's file. We're going to pull up the file right here. And which line of code is giving you this issue? Well, the train function, but which line of code are you on? So I'm assuming it's when you start using train. Let me try to replicate it and see where the issue is. So let's see. My eyes blurred. Oh, would I recommend playing Dark Souls? Oh yeah, I love Dark Souls. I was literally telling Chelsea this morning. I was like, Dark Souls is so awesome, and she's like, Dark Souls. Dark Souls is an amazing game. Tons of fun. Huge fan of Dark Souls and that genre. Great stuff right there. I think your holdout. Oh, let's see. I think the holdout is the wrong. I'll look at that later. Let me see something real quick. I'm gonna hop over and show the screen here in a second. Okay, training rows with the remainder being the holdout. Yeah, it's crazy how we made that big of a holdout. Okay, so here we are. Is it one line 191? Good. Okay, let me see if I get this error right here. I am running the code in the background. Error not recognized. Resampling method. Okay. So let's see. I see what you're saying with the error right there. Okay, error not recognized. Resampling method. Let me check some stuff. Oh wait. Oh, I see it. Here, let me show you, Chloe. I see the issue. Okay. So, okay. Let me hop over here to the main screen and I will explain what's going on. I see it. Okay. So there's two things right here. There's the fit control and then there's the model. So this is where we build the model right here. And this is where we do the fit control. So what does the fit control control? What does the fit control do? So what is the point of the fit control here? Like, why do we have a fit control? To control the what for our model? What does the fit control do? Any idea on what the fit control does? What does the fit control do? And there's a big hint, and I'm going to double check which fit control we're using. There it is right here. That's the big hint right there. So we're using cross validation right here. Vanilla 5-fold cross validation. So the fit control is controlling the cross validation. So this needs to be CV right here. So that should fix it right there. And it looks like we have an issue right here. It says let's see here, warning, object, It's mad about something. We're predicting usage. Wait a minute. Usage should be quantitative. Let's look at the training data. Let's look at usage. Usage is quantitative. And let's find out what's going on right here. So the fit control, let me look at the model. Set up fit control so that the vanilla 5-fold cross-validation is being used to estimate the generalization error. Then fit the model, ignore the warnings, predict from a rank deficient. Those aren't predict from rank. Oh, those are the warnings. Good. Ignore the warnings. This just means that some correlated predictors. Yes. Name the object created by running train to GLM. Does this make sense here, Chloe? What's going on? We should have the GLM net now, or the GLM, just the GLM, and we have our model right here. We can look at the best tune. I think we used vanilla, so there are no parameters. So fit control should use method CV, because the fit control right here, which is the train control. So the train control, let's just take a look at train control real quick. And so we should get it over here. When you're running train control, this is how you're doing your validation. And you can see right here, this is not how we're doing, this is not the model we're making. This is how we're validating our model. Does that make sense? So this train control object, which we're making right, where'd it go? Move down the screen. This train control object we're making right here because we're saving into it. This object we are creating right here, which is saved into fit control. We have tons of options for how to make it. We can use boot, boot 632, optimize boot, boot all, CV, repeated CV, low CV, low GO CV, none, OOB. So you can use, yep. So this isn't the method that you use for train, because the method for train, like this is a generalized linear model. The method here for train is what kind of model are you fitting? And then the method here is what method are you using to validate? So under train control, just to repeat, train control has what method are you using to validate your model, and then train right here, which is not train control, train right here has what method are you using to make your model. So good stuff right there, Chloe. You're right on track. We got lots of time for this assignment, so you're on track. You're doing great. You hit a small error. You figure out what it is. Yeah, it's just something small, and then when you see, you're like, oh, it's this train right here, and then this train control versus this train. Even I have to take a moment and be like, okay, where's the error at? And then you get these warnings right here, and you're like, whoa, what's going on with these warning methods? Highly correlated predictors. So you can get all this right here. Rank deficient means, what the rank of a matrix means for any math people out there, they would know if you have something that is linearly independent, you have like 5 equations, the rank of that should be 5 if I'm doing it correctly. But if it's rank deficient, then you have linear dependency among your equations. So if all of our vectors in this data are linearly dependent, or independent, I should say, we would not have rank deficiency. But because there's some dependency within this, some linear combinations, especially you see it right here with low, high, medium, mean, Q1, Q3, these are probably created from the variables in some way. So we're going to see some sort of dependency, and that's going to create rank deficiency among the variables. And it's not the end of the world. It's just telling you your data's got problems. Well, what data doesn't have problems? You know what data doesn't have problems? 201 data. Let's bring up some 201 data here. And Chloe, excellent job. I'm just going to say great job right there. Great job in the email, because really, I'm glad people are looking at this, and then they try to figure out, the issues beforehand, because there's so many little things. There's so many little errors you can hit. And then even I have to pause and be like, okay, what's going on? Vol success tips. When did those appear? We were pulling up some 201. We're going to pull up some 201 homework right here. Dan, and who else was here for 201 homework? Dan and Meryl, are you ready for some 201 homework? Let's go right here and pull up 201 homework. I heard question 2 on chapter 16 homework. So let's go to replace questions. Chapter 2. Here it is. Chapter 16 on chapter 2 homework. Okay. So this is the homework we're doing right here. So let's take a look. And what do we have? A company is sued for job discrimination. Oh, awesome. Then we'll do a quiz here next if you want. We'll do some quiz question stuff. So a company is sued for job discrimination because only 26% of the newly hired candidates were minorities when 34% of the applicants were minorities. Oh, good to see you here, Kelly. So, Kennedy, sorry, I looked too quickly. Good to see you here, Kennedy. Is this strong evidence that the company's hiring practices are discriminatory? So is this a one-tailed or two-tailed test? So when you look at the tails of a test, what do the tails of a test mean? Well, tails of a test are when we talk about either a less than, greater than, so I shouldn't have written that because I can't quick erase it, greater than, or a does not equals to test. So when you think about this, I think Kennedy knows it's going to be a one-tailed test because they're not going to look for kind of too many. They're only going to look for if there was too few people hired of a minority. So they're only doing a one-tailed test right there to see if it's too few, like less than this amount was hired. In this context, what would type 1 error be? So importantly, we need to know what, do you have a visualization 10 up yet? I should get that up this week. We got to do something fun. We got to do something fun right here. Yeah, we can do that. We'll do a little tool right here. Then we'll do some 320. That's a cooking. I think I burned my thumb a little bit. Not discriminating. Not discriminating. And so what would a type 1 error be? Someone explain just briefly what a type 1 is. Remember, in a type 1 error, the null is what? In a type 1, the null is what? True, but we reject it. So the null is going to be true right here. And we're going to reject it and say we have evidence of this. So it is true that the company is not discriminating, but we reject it in a type 1. And if you're watching, in a type 1, the null is true, but we reject it because we make a mistake. In a type 2, the null is false, and that's an F right there, and we fail to reject it. So in a type 1, it is true that they're not discriminating, but we reject that, and we say we have evidence they are discriminating. So they'd be falsely accused of discriminating. We lost our project right here. We lost it. So in a type 1 is deciding that the company is discriminating when in fact it is not. So there we go. It's mistakenly saying they are discriminating. What would a type 2 error be? Well, a type 2 is going to kind of be the reverse of this. In a type 2, remember the null is false and we fail to reject it. So how does it look when I draw this out right here to say the null is false? Well, the null is false, but we fail to reject it. So the alternative is true. So the null is false. So maybe I shouldn't put that X over it saying we're rejecting it. The null is false and we fail to reject it. So the null is false, but we fail to reject it. And that is a type 2. In a type 2, the null is false and we fail to reject it. They're not discriminating. So this one, in a type 2, they are discriminating, but we say they're not. Because in a type 2, the null is false, but we fail to reject it. It is false that they are not discriminating. They actually are discriminating, and we say that they are not discriminating, but they actually are. Does this make sense? And a lot of times visualizing it helps. Remember, in a type 2, the null is false, so go ahead and write false next to the null like I did, but we fail to reject that, which means we continue to believe it. So it is true that they are discriminating because the null is false, and thus we say that they are not discriminating when it is true that they actually are. So be very careful. Decide that the company is not discriminating when it actually is. And it's so easy. I've made mistakes on this. One of the first errors that somebody actually said I made in Stat 201 was reversing a type 1, type 2. They actually went to, I think, Charlie Quick, who was the director of Stat 201 at the time. And they were like, Brian Stevens told me this in Stat Lab and he was wrong. And he was like, Brian, you understand how to do a type 1 to type 2, right? And I was like, yeah. And I told him correctly. And he's like, maybe you just got it reversed or they got it reversed in their head, but whatever. But they said Brian got it wrong. So I've been, maybe I got this wrong. I know I've gotten it wrong once at least. So it's tricky. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. Boom, don't forget it. Practice right there. So what is the power of a test? I think Dan was saying this in our last office hours, but the power is, during Kahoot. The power of the test is the ability to correctly reject the false null. That is literally the definition of power. The definition of power is power equals the ability of the test to correctly reject the false null. So what is power mathematically? Power mathematically is going to be 1 minus beta. What is beta? Beta is a what? What is beta? Beta is literally a type 2 error. That's what beta is. Beta is literally a type 2 error. So when you look at this, it's not making type 2 errors. It's everything but making type 2 errors. So the power of a test is not making type 2 errors. It's when you don't fail to reject the false null. So because either we reject the false null, which would be the right thing to do, or we fail to reject the false null, and this is when we don't find results when results actually exist. So let's look right here. What is meant by the power of a test? It's going to be the ability to find discrimination when discrimination exists. Because if we should reject the null, then they are discriminating. So D, the power of the test is probability of correctly detecting actual discrimination. Great job right there, Kennedy. It's like a word twister. If the hypothesized test is tested at the 5% level of significance instead of the 10%, what will be the effect on the power of the test? And this is where things get a little bit tricky right here, and I've made mistakes on this one. Here's how it works. There are 3 things that impact beta. We have sample size, effect size, and alpha. I couldn't think for a second. As these go up, beta goes down, and 1 minus beta would go back up. And 1 minus beta right here is power. So what we see right here is that when effect size goes up, beta goes down. When sample size goes up, beta goes down. When alpha goes up, beta goes down. When beta goes down, power goes up. These two right here, I keep repeating this, are not complements. Those are not complements. They are inversely related, but they are not complements. Alpha is a type 1 error. If you increase your type 1, you decrease your type 2. Beta is a type 2 error. So with this right here, we are going to test it at the what level of alpha? Let's look at this. Is tested at the 5% level instead of the 10%. So we're going to test it at the 5% level of significance. Do you want to know which question I want to? Yeah, tell me which one you want to go over and we'll do it next. You got it. Whichever question you want to do next, we will do next. It's going to be tested at the 5% instead of the 10%. So the power of the test must do what? We have just made alpha go down. It's going to be tested at 5% instead of 10%. So now, since we made alpha go down, power will do what? If alpha is lower, the power of the test will be what? If alpha is lower, the power of the test must be what? If alpha is lower, the power of the test must be what? It'll go down because alpha follows the power. So the power of the test will decrease because the significance level has decreased. There we go. That should be it. Whew, deep breath. I don't know how I used to make mistakes on that one. I think because I think it's at a more significant level. That's what I used to think is like you're at a higher level of significance, but it's literally just saying that alpha has gone down. I wish it would just say that because alpha decreased. So the lawsuit is based on 87 employees. Is the power of the test higher, lower than, or the same if it was based on 35 employees? So comparatively, would it be higher at 85? So we're going to compare 85 to 35. So is 85 more powerful or less powerful, the same? Yeah, let's do. We'll do that one here next, Dan, and then we'll do a 321. You got it. Question has 4 parts, A through D, and starts with which of the following are true. Cool. Yeah, let's do that. We'll do that one next. So it's based on 87 employees instead of 35. So which of these arrows are we going to use? The black ones or the red ones? So 85 instead of 35. That's a larger sample size? I think it's going to be A, right? Because 85 is a larger sample size, and if it has a larger sample size, it'll have a larger power. So due to the larger sample size, we're going to see a larger power. So the sample size is larger, and thus the power of the test is larger. Beta is smaller, but beta is the complement of power. I keep on closing that down. So it's higher because we have an increase to sample size. Yep. Little tricky right there. Little tricky. And we got 44% done. Wow. There we go. There we go. The wow button. Let's go over here and take a look at chapter 16 quiz. Okay, Dan. And then we're going to do some 320 after this, so stay tuned. 320. I think they're working on number 9 homework. Okay. Oh my gosh. We got to find this. Can you tell me the very, very start of the question? It says, which of the following are true or something? So it says, the question has 4 parts, and it starts with which of the following are true? Oh my gosh. There's job discrimination. Wait, let's do that one. Which type of error is made when a true null hypothesis is rejected? Type 1, when the null is true and we reject it. Which of the following is made when the false null is not rejected? Wait, false null, fail to reject. There we go right there. Can you go over the working men question? Yeah, let's see. We might do 2 more stat ones. What is the probability that a test correctly rejects the false null? It's going to be the power of a test. Look at this. We're just clearing out questions. What is the name of the threshold by which we reject the null? That is alpha level. And what is the name of the difference between the value of the null and the true population parameter? That's going to be our effect size. Something we talked about just a second ago, but we didn't go into too much detail on. Where is this? Where's the question? Okay, here we go. I couldn't find it, Dan. I was like, where is the question? Where's the question that we're looking for? Okay. Which of the following are mistakes that can... Wait, is this it? Starts with which of the following are true. Is this it right here, Dan? Ah, here we go. We found it. Okay. So this is the question we were looking for, and then we're going to do the working man, then we're going to do some 320. Let's see right here. Here is the question. Let's go take a screenshot of. Hey, what's up, Alan? So good to see you here. Let's do this. Let's do this question right here. So which of the following are true? Briefly explain. Okay, let's do each one. Okay. Using an alpha level of 0.05, I know it had to be the last one, right? Using an alpha level of 0.05, a p-value of 0.02 results in rejecting the null hypothesis. How does it work whenever we have an alpha level? What does alpha literally mean? Someone put in the chat what alpha literally means. When you have an alpha level, if we have alpha, and let's say it's like 0.05, what's the deal with alpha? What is the deal with alpha? Like, what is the point of alpha? That then we have a p-value right here of 320. You bet. We're going to do some 320 here in probably about 10 minutes. You got it. Tons of 320. We're going to do 2 more 201 questions because I don't think Kennedy had one yet. And then we'll do 320. Lots of good times. I love it. I used to do a queue when I'd wait tables. What does this mean right here? If alpha is 0.05 and the p-value is 0.02, what does this mean? And what does alpha mean? What is the point of alpha? So you should have a good note like alpha. Whenever you hear alpha, you're like, oh, that's the point at which what? Oh, no one knows? What do we use alpha for? What's the point of alpha? Beyond alpha, there is significance. Exactly. Kennedy, great job right here, Kennedy. Kennedy, 1,000 points. We haven't been giving out off star point lately, but Kennedy, great job. So this is very, very true right here because whenever a p-value is lower than alpha, we reject the null. That's the whole point of alpha. Alpha is literally just a bar, and you set this bar wherever you want, and then below that bar, you reject the null. So we're going to definitely reject the null right here. So did I say anything about how alpha is connected to sample size? What do you think about this one right here? The alpha level depends on the sample size. Alpha is just a value you pick, usually 0.05. Usually we just pick 0.05. It's classic alpha. So does alpha depend on sample size? No, they're completely independent. Alpha and sample size are two different things. There's no alpha sample size connection. They're both connected to power, but they're not connected to each other. You can pick whatever alpha you want. It's independent of your sample size. With an alpha level of 0.01 and a p-value of 0.08, okay, so alpha level here is 0.01 and a p-value, this is not to scale. The p-value was 0.08 for the p-value. Results in rejecting the null hypothesis. So what do you think about this one right here? So we get a p-value of 0.08 and an alpha level of 0.01. Does this meet our criteria for rejecting the null? Does this meet our criteria right here for rejecting the null? So it says if we get a p-value of 0.08 with an alpha level of 0.01, we'll reject the null. Would this reject the null? So do we land in this region where we can reject the null? And the answer is definitely what? What do you think? No, we definitely don't. So this is 100% false right here because we did not land below alpha. To reject the null, we need to land below alpha. And let's look at this one. This one says something a little bit different. It says you have an alpha level, so it's alpha right there, equals to 0.05. So let's only put alpha on the screen right here. With an alpha level of 0.05 and a p-value of 0.10, means the null hypothesis is true. So what are the only two things we do with the null? We only reject the null, and we only fail to reject the null. We never say the null is true. What this would mean is what we saw would occur about 10% of the time due to random chance variation, given that the null is true. So it means that our value that we observed is possible, a value like it or a value more extreme. So this one is also false, and we would not see a value, we would not say the null is true. We would just say that it seems that the null is possible and we fail to reject the null or we do not reject the null. Classically, they say fail to reject. Some people say retain the null. Some people say I do not reject the null. Don't use words like I accept the null or the null is true. Those are really bad things to say. So let's take a look and then we're going to do Kennedy's question next. Thank you so much, Kennedy. So this one was true. This one right here, the alpha level depends on sample size. They are dependent of each other and cannot determine the end until the alpha level, yes. Wait, this statement is false because the alpha level is set independently It does not depend. Exactly. They're independent. It does not depend. The other one tricked me. Tricked me for a second right there. With an alpha level 0.01, nope. Because a p-value greater than the alpha indicates the null. Nope, nope, nope. Because only a p-value less than alpha results in rejecting the null hypothesis. And we don't reject the alternative. We only reject the null. So you can read the wording right here. This is the only one that makes sense. We never say the null is true, and we do not reject the alternative. We only reject or fail to reject the null. This statement is false because the p-value greater than alpha only indicates that there is enough evidence to, nope, we don't accept the alternative. So I think it's going to be the bottom one. This statement is false because a p-value greater than alpha indicates the alternative. No. This statement is false because a p-value greater than alpha only indicates that there's not enough evidence to reject the null hypothesis. So as in, we just say we cannot reject the null. As in, when we say we do not reject or we fail to reject and we should get it, tells we got it. Come on. Oh no, did the internet break? Oh, we got it. Okay, let's see. Kennedy had a question. Can we go over the working men question on 201 homework after this? Let's see if it's also on the quiz. So let's see. We did a bunch. So let's see the working men question. Here we go. We found it, Kennedy. Let's give it a shot. You ready? A random poll of 600 working men found that 11% had taken on a second job to help pay the bills. Estimate the true percentage of men that are taking on a second job with a 95% confidence interval. Okay, this is rather interesting because that's a huge sample size. So we have right here the data. And let's go ahead and bring this over to a worksheet. And we need to identify some of the notation. So I need some help here. Who can help me identify any of the notation? Who can help me identify any of the notation? So we have right here 600 working men. And we have here 11%. We have here a 95% confidence roll. So what would this be? What do we have right here? Any notation to help me out, and then we'll do some 320 right afterwards. I'll even give a hint, because we're going to need an additional thing right here. That's a huge hint right there. So always try to identify the notation with these problems. I need one notation. Oh no! Sample size, exactly. Nice job there, Kennedy. There we go, p hat. And this would be z equal to 1.96. This is where you can go to the David M. Lane applet and get the z-score of 1.96, and that's the classic z-score we use for a 95% confidence roll. So from this, we need to use the interval p hat plus or minus z star, p hat q hat over n square root. And that is going to be nice job right there, Kennedy. That's exactly right. And so now we just plug in the numbers. Let's plug in the numbers. 0.11 plus or minus 1.96 square root 0.11 times 0.89 over 600. And this should give us the 95% confidence roll right here. So let's go ahead and take a look. And square root. And we've just found the margin of error right now, which is about 0.025. So that's a really nice number. And then we got 11. So I always like to do this right here where we go 0.11 plus or minus 0.025 because that's the margin of error. And so we should have the interval created right now. And it really goes down to identifying your notation. So the big thing, hey, Meryl, great job with the points right there. Oh, you're about to get silver tier. That's awesome. You'll be at silver tier in just a moment here. So make the 95% confidence roll, round to 3 decimals, and it's going to be 0.085. And this one should be that. And there it is right there. There it is right there, Alan. Oh, 100,000. Jeez, Alan, that's amazing. I love it. I love seeing all the points. What does the confidence roll say about the pundit's hypothesis? So a pundit claims 8% of people. Can you go over the quiz where it states before lending someone money, banks must decide? Yeah, let's do one real quick. We got enough time. Then we're doing 320. You got it. Let's do it because then it's like a nice break. Then we hop to 320 and do 320 for a good bit. So what does this say about it? Because 8% is what? So strong evidence that. So what do you think about this? Since 8%, is it contained in the interval or not contained in the interval? is it contained in the interval or not in the interval? And we what it then? So is it in the interval or not in the interval? Do you see 8% in there? 8% right now is outside the interval. So it's not in the interval. We have strong evidence that more than 8%. We think from about 8.5 to 13.5. So it's not in the interval. So we have strong evidence that more than 8%. This should be correct. Yes, we did it. We did it. We got it, everybody. Okay, last one right here. Dan says, I sleep Ben most of my points. Let's do this. Meryl, let's do this. Did you lose 1,000 points last week, Meryl? This is just for Meryl right here. Meryl, how many points do you have right now? No, I can do it. Make it easier. Let's do this. We're going to do a quiz right here. Betting. Don't bet on this, other people. Well, okay, if you're here, you can bet on it. Betting on is your name, Meryl. Okay, so option, there's only, don't bet unless your name is Meryl. I mean, you can still bet on it, but don't say no. And I think this has got it. So, okay, so the betting should be on the screen. Is your name Meryl? Yes or no? 0 is yes and 1 is no. 0 is yes, 1 is no. So, and I think that'll even out the world. Let's do the last go. Tutoring at the math place and getting tutored by Brian. Awesome. We got this. And let's see right here. What was the last question we we're going to do? I think Dan said, can you go over before lending money? How much do I need to? A silver tier, I think, is 2,000. Are you not there yet, Dan? How close are you, Dan? How close are you? Dan, you should be pretty close. I think you should be close to silver tier. The tier idea has worked out really well. People really like the tiers. Like that worked out so well. A p-value is smaller than level of significance. What should we conclude? We will reject the null when the p-value is lower than alpha level. Meryl, you got to bet. Meryl, if you're here, bet. Which of the following is correct for interpretation of a p-value that is not very small? What we saw in the data is not that surprising. We failed to reject the null. That sounds good. We've witnessed... Oh, so it's not that surprising. Good. That's correct. Okay. Wow, we've almost done all of these. Which of the following are mistakes that can be made in a hypothesis test? The null is true and we reject it. Okay, that's a type 1 error. The null is false and we fail to reject it. So 1 and 3. Which 1 and 3 are a type 1 and a type 2 error. The null is true and we fail to reject it. That's correct. Got scared there. I think, am I missing it, Dan? Here we go. Have we almost done all of them? Holy mackerel. Look at that. That's, wow. Okay, wait. I don't know which one we got right here. Okay. Ignore that answer. I know. Who wants to bet that their name is Meryl? Bet quick. Before lending money, banks must decide whether the applicant will repay the loan. One strategy used is a point system. Loan officers assist. Kennedy's betting. You got to make sure to bet the amount too, Alan. Loan officers assist with the application, totaling the points. The higher the point total, the more convinced the bank is that the money is safe, the loan is safe to make. Any applicant with a lower point total than a certain cutoff is denied the loan. We can think of this decision as a hypothesis test. Since the bank makes its profit from the interest collected on repaid loans, their null hypothesis is that the applicant will repay the loan and therefore should get the money. So everyone is named Meryl today. Only if the person scores below the minimum cutoff will the bank say that they can reject the null. Okay, we'll end the betting right here. Stop the betting. Win out the points. There we go. And I think we had... Oh, I think, Kennedy, I think you put it in... So, Kennedy, I think because you put it in the brackets. Here, wait, Kennedy. If you want to bet again, you have to put it without the thing like Alan and Harrison did. So I opened it back up if you want to bet again and get some free points. Oh no, Meryl, the betting's back open. So Alan's betting again. We'll see if it lets Alan bet. Okay, so free floater, you get some free points right here. The max bet's 1,000. You're just betting on if your name is Meryl. And we just, everybody's name's Meryl today. It's all Meryl today. So feel free to bet. Okay. So the null hypothesis here. What is the null? You're welcome, Kennedy. We're just here to have fun. We're here to relax. We're here to have a good time. Oh, Kennedy, Meryl's betting all her points. Let's see right here. Pick winner. There we go. Everybody's a winner. I think that's for Kennedy. Yep. There we go. Look at that. Wow. Meryl just got 1,960 points right there. Alan's just watching those points. Check out your new points. So the null hypothesis, if I could type today. The null is lend money. The alternative is going to be, we got to have fun. We're Stat Nation. Don't lend money. And then we're going to do 320 right after this, because we did a lot of this. We did really well in this. Okay, so the null is to lend money. The alternative is to not lend money. So let's be very careful right here as we read through the questions. And the questions say, when a person defaults on a loan, what type of error did the bank make? So what would the bank have to do? The bank would have to lend them money. So what is the bank going to do to lend money? So if the bank lends money, are they going to reject the null or fail to reject the null? If the bank lends money, would they reject the null or fail to reject the null? If the bank lends money, then would they reject the null or fail to reject the null? If the bank lends money. So when a person defaults on a loan, what type of error did the bank make? So what did they do? Did they reject the null or did they fail to reject the null if they're lending money? And if they lent money, they failed to reject the null. And since they failed to reject the null, you're so close, Dan. So close. You'll get there by the end of the semester. You'll get to silver tier. And if not, I'll make sure you get there. So in a type 2, they fail to reject the null. Does that make sense? You get like, it'd be a type 2 because they're going to fail to reject the null here. And then this is going to be a type 1. What kind of error is made if the bank misses an opportunity to make a loan? So then they don't lend the money. So they're going to reject the null and say they have evidence that they should not lend the money. But this is when the null is true, they should lend the money. The null is true in a type 1. And so they lost an opportunity. They rejected the null. So this is a type 1 error, Suppose that the bank decides to make the cutoff score 250 from 250 to 200. So they're lowering the bar. Is that analogous to choosing a higher or lower value of alpha for a hypothesis test? Okay, so we got to be really careful right here. So when you think about what alpha is, it's when you reject the null. So if they go from 250 to 200, what will they do more often right here? Will they give out more money or less money? So if they go from 250 to 200, remember they say this person must meet this criteria. The person must be over this bar and then they'll lend them money. So are they going to give out more or less money? Would they give out more or less money? So we're going to bring the bar from 250 to 200. So would the bank give out more or less money? Because you must have a credit score of this to get the money, and then they're going to lower the bar to this. They're going from 250 to 200, and if you meet this bar, you get money. You get the loan money. So they're going to give out more money. So in other words, it's going to be harder to reject the null. If it's harder to reject the null, I think it is going to be a higher level of alpha because it's harder to reject the null. And when is it harder to reject the null? When you have a higher level of alpha. Alpha is the evidence you require. So they're saying it's going to be harder to reject the null here. We're going to make it harder to find the evidence to not lend the money because we need more evidence that they have bad credit. So it's going to be a higher level of alpha because it's going to be harder to reject the null. Lower level of alpha. Excuse me. Lower level of alpha. Sorry, I got reversed right there. When you have a lower level of alpha, you're setting up your bar so that it's harder to reject the null. I spoke too quickly. If you go from an alpha of, let's say, 0.05 to an alpha of 0.0001, then you make it so you reject the null less often. So when you go to a lower level of alpha, you make it harder to reject the null. Some people call this a higher significance level. It can get confusing with the wording, but this makes it harder right here, so harder to reject. It is harder to reject when you go from an alpha level of 0.05 to an alpha level of 0.01. So that would be a lower level of alpha. What impact does this change in the cutoff value have on the chance of a type of error? So when you lower alpha, what will happen to a type 1 error? If you lower alpha, type 1 is going to do what? So if you remember back from our notes from earlier, and you got to be careful because this is a connected question. If you lower alpha, alpha is directly connected to type 1. Alpha is type 1 error. So this will mean you'll have less type 1 errors. you'll actually give out more loans to people, but you will have more type 2 errors. So type 1 and type 2 errors are inversely related. So you will decrease your type 1 errors and you'll increase your type 2s. Woo, get a little bit scared there sometimes. So easy to make an error, but does this all make sense right here? And hopefully the graphics also help with it, kind of seeing as we plot it out and draw it out. You always want to kind of do drawings like this to make sure you understand that alpha and beta, what they are. Alpha is your type 1 error rate. You get to decide it. Usually it's 0.05 by default. And beta is your type 2 error rate. And your alpha and beta are inversely related. If you decrease alpha, you increase beta. And beta and power are literally the inverse of each other. Power is 1 minus beta. So hopefully these make sense right here and how they're all connected, because these are the three things that control beta right here. They also control power, but these three things are what impact beta right there. They're all inversely related to beta, and alpha and beta are not complements of each other. Let's do some 320. 320, where are you at? Alan, are you here? Let's see who all is here for 320. Let's go in here to assignments. Let's pull up assignment number 9 right here. I almost clicked the solutions. Everyone's like, come on, do the solutions. Let's operate here and let's go down to question number 2. I think people were saying they had questions on question number 2. Alan, what do you have questions for? I think it was early on. Someone said they had a question on number 2. It was Mary. Mary said, can you go over question 2? So let's see. My question is in terms of how to interpretation of coefficients. Which ones? I was on Discord a moment ago talking to someone right before office hours. And question 2, we should be here in a second. Here we are with question 2. Oh. Question 2 is all about interpreting coefficients. So the interpretation of the coefficient of adds. So when we talk about this right here, how do we start our interpretations? So ads right here, let's see. I think it gives you a little bit of information on it. So in marketing analytics, the relationship between sales or product and the amount of money spent on advertising is often studied. What follows the output of making a model based on thousands of dollars in sales, based on the amount internet advertising ads in thousands of dollars in the room, which is placed in the size of product. 2 individuals who differ in ads by 1 are expected to differ. Be careful. Be careful. Be careful. Are these individuals right here? Are these individuals? Are these individuals that we are selling? So are these individuals right here? Are these individuals that we're selling? You're close. We need to do some working on it. Are these individuals that we're selling? They're products. So we have a product that could be placed in the bedroom, a product that could be placed in the office, a product that could be placed in the kitchen. So we have a product that is a large product or a small product, vice versa. And so we have 2 products. But what do you notice about this regression output right here? What do you notice about this regression output? Like, how many variables are there? There's technically 3 variables that make this model. There is ads, there is room, and there is size. But there's indicators here. So this variable right here is quantitative. And this variable right here is categorical. Sure, let's do that. And this variable right here is categorical. And this variable right here is categorical. So kind of gives a little more context. You're welcome, Dan. Excellent work. Excellent work. We're doing some interpretation right here. We're going to interpret these variables, kind of giving ourselves some context for these variables. And room is a variable and size is a variable. Is this making sense here, Alan, that room is a variable, which room has 3 levels? Why do we not see all 3 levels? Why don't we see all 3 levels to room? So it might be like, wait a minute, room only has 2 levels. Room only has kitchen and office. But why don't we see bed? Why don't we see bed? Where's room bed? Where's size large? Where is size large right here? I see bed right here. Here's the hint. So what's going on with these right here? Awesome. Great job. Excellent work. Seeing class, Kennedy. Excellent job during office hours. Great job. Great review. So what you got to do is just got to review it. More you review it, more practice you get. Come here, ask those questions. Excellent work, Kennedy. Great job. or I should say Meryl. Everyone's Meryl. So we have here the reference level. These are the reference levels. So when you look at the coefficient of room kitchen, you will compare it to room bed. You have clones now. It's the Clone Wars. It's the Meryl Clone Wars, the Meryl Clone Wars saga. So we have here size small, and size small will be compared to size large. That's what the coefficient means right here. And remember that these are sales in thousands of dollars. So, but how many variables do we have for this? One or multiple variables? Do we have one variable in this model or multiple variables in this model? How many variables do we have in this model? One variable or multiple variables? And this is what you have to know when you're interpreting. Multiple. So what was missing? You said two individuals who differ, but we need something right after we say that. Because it's a multiple regression, we have to say two individuals who what? You can start out with two individuals, blah, 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 who differ in there, or you can say two individuals who differ by, but you don't want to say two individuals, say two products for this. So you want to start with two products. Be very careful on the test because you can't just say two individuals. I might change it up. I might have it be for squirrels. You never know what I'm going to have it be for. So hopefully, you know, that I'll give some context or the equation will give some context and then, you know, type as much as you can to make it make sense. So since it's a multiple regression, what do we have to say? Since it's a multiple regression, what do we have to say? We have to say two products that are what? Two products that are what? Oh, 320, we need you to rescue us. Two products, not identical, but are otherwise identical, but differ in their ads spent by $1,000. So two products that are otherwise identical, but differ in their ad spend by $1,000 are expected to differ in their sale revenue, because that's what we're looking at, right? We're looking at sales. Yeah, we're looking at sales. So two products that are otherwise identical, but differ in their sales by $1,000 are expected to differ in their, oh my gosh. Let me try this. Two products that are otherwise identical, but differ in their ads spent on the product by $1,000 are expected to differ in their sales by $969.43. I'm just timesing this by 100, where the product that has more money spent on the ads is expected to make more money. Two products that are otherwise identical but differ in their money spent on ads by $1,000 are expected to differ in their sales revenue by $963.94, 94.3 cents, where the product that has more money spent on its ads is expected to have a higher sales revenue. Does that make sense right there, Alan? Did that all make sense as I said it? It's a lot. But if you look at the key components right here, we need to have otherwise identical. We need to give, you know, differ by one. You could technically say two products that are otherwise identical but differ in their ad spent by $1 are expected to differ in their sales revenue by 96 cents, 0.94, 96.94 cents. Exactly. So Dan, you're almost Dan. Dan, check your points here again. Where's it at? Is the next one similar to this? I think so, but I think it's gonna be categorical. Did I type it wrong? We have so many people. I love it. Check. You know, we're getting so close to the end here. Check your points. Check your points again, Dan, if you want. And then I also made it so you can have another milestone. But check your points again, Dan. Let's look at the next one here. You've been here all semester, Dan, and we've only got this is the second to last week, so I want you to have some points to flex. I didn't change the hours, so you can still track your hours. But I think Meryl's got Meryl. Oh, Meryl, literally, I didn't change anything, Meryl. You literally just got silver tier because you doubled your points. So you literally just got it. So nice job, Meryl. Silver tier back. Love it. And Dan, and Meryl, I'll throw you some more points here at the end. Remind me, be like, Brian, you owe me some points. Interpret the coefficient of room kitchen. Okay, so what do you have for this right here, Alan? What do you have for this one? How do we do this one? There we go. We're going to fix Meryl's points too here while we're talking. I get really nice at the end of the semester. So since I based it on the individuals earlier, I'll send you one. Since you have it on individuals, you have to change it to products. You're welcome, Meryl. Check your points again if you want, Meryl. So this one is room kitchen, which is a categorical variable, which we need to compare to the bedroom. So there you go, Meryl. You're right. You're almost a gold tier. You're so close to gold tier, Meryl. In just seconds, you got there. So two individuals, it's like Christmas. Two individuals who differ. But well, so and you can see whenever you say it, think about it. Does it make sense? So this is a big thing for the test. Really good practice right here. So we so you have two individuals who differ in room kitchen by one are expected to differ negative 0.123 when one of the people has a kitchen and the other has a bedroom. So there's some issues. One, we did not say otherwise identical. We always say that when there's a multiple. Two, we gave the wrong units. We talked about people versus products. Three, we don't say differ by one. We always compare two individuals who are otherwise identical, well, not individuals, two products that are otherwise identical, but one product is placed in the where. So try working with this, Alan. So I'll let you type in the chat, and then when you write this one, delete it, but type this out and see if you get it. Two products that are otherwise identical, but one is placed in the blank and one is placed in the blank. The product that is placed in the blank is expected to have this much more in its sales. So remember, sales is in thousands of dollars. So two products that are otherwise identical, but one product is placed in the blank and the other product is placed in the blank. The product that is placed in the blank is expected to have this much more sales. Oh, yeah. Which one is that, Ryan? Which number is that, Ryan? That's 320, right? I think it's 320, is it? Which, is that which number is that, Ryan? Two products that are otherwise identical, where one product is placed in the kitchen, the other is placed in the bedroom. Exactly. That's got it right there. Two products that are otherwise identical, and then keep going. You're on the right track with that, Alan. Yep, C2. There we go. You have to juggle a lot of questions in your head. Oh, I think I know what you're talking about. Ryan. So compare the differences between the two models. So we have right here, among days with the same effective temperature, how much smaller is demand? So I think I have to make these models right here. Let us compare the average demand for rainy and non-rainy days after accounting for the temperature. Fit regression model predicting demand. Okay. So we need, is it EX5 bike? Okay. So I think, okay. So what is the overall demand for rain, non-rainy days? Is there a difference in average? Run associate. Okay. And so we're predicting demand from weather. Data equals EX5 bike. I didn't load up EX5 bike. There we go. And we're going to increase the screen right here. And there we go. So now we're loading in. They differ by 1,000 are expected to differ by... no, but they're not going to differ by 1,000. So the units, remember the units of the coefficient are where the product of the bedroom has more sales than the... there's still an issue. I'll say it here in a second. I'll try to revise it again. But there's still an issue with that. So it's two products that are otherwise identical, but one is placed in the blank and the other is placed in the blank. The product that is placed in the blank is expected to have, you could say, lower sales by this many dollars. Remember, it's in thousands of dollars, but two products that are otherwise identical, but one is placed in the blank and the other is placed in the blank. The product that is placed in the blank is expected to have lower sales by this much compared to the other one, you could say. So that's why it's always the indicator versus the reference. We're going to compare them. And so, but they're not going to differ by an amount because we're just comparing one product is placed here and the other product is placed here. Yeah, exactly. So they don't differ by a 1 unit change. The 1 unit change on the indicator is one is placed in this area and the other is placed in this area. You can try it again if you want. Give it another shot. Just practice makes perfect. That's why we get to the test and people they don't know how to do it. And I'm like, no, because even with notes, it can be tricky. You'll notice me sometimes make a mistake. So here is the difference here between the rain and the no rain days. Here is the difference right here. The difference is 907. And then we're going to make a model right here where we control for the temperature, I believe. So now we need to make a linear model right here. We do demand with this. Doesn't matter which ones we put in first. And then we go there, and I forgot the date equals. There we go. We can visualize the model, and we'll get to see two separate lines right here. So here's our two lines. We can summary the model. And here's our summary of the model, and there's the coefficient. So if you remember previously, we had this, and now we have this. So if you want to see about if they vary by more than 15%, if this is a rather large difference, I'll let you think about how to compare these and maybe talk about them numerically. But does this make sense here, Ryan? What we want to do is we want to compare these right here. We're looking at the difference that we see just normally due to weather, and then we're looking at the difference right here after we account for effective temperature. Does that make sense right there, Ryan? So these are the two numbers that you're comparing, and if you want to see if there's a difference of more than 15% change. So probably think about this one right here, which is your original number, and then think about what 15% of that is, and then to be like, okay, here's the, yep. And so you're just trying to see, like, is there a massive change between the numbers? I think great stuff. What additional questions are there? I might break down and drink coffee today. I shouldn't. I need it. I don't want coffee. I need coffee. We will see. We had a really great office hours today. We did a ton of 201. We did some 320. We even did some 474. We did all classes today. We did every class. Is it necessarily bad if it's large? No, it just means that including the one variable kind of changed. When you add stuff to a multiple model, and here's what you can do. Here's the model without it. And you see the coefficient is now that 907. And then when you add stuff to the multiple model, what happens is the other variables start to explain also, and they kind of step on each other's toes. So effective average temperature is also explaining, and so is weather. So due to the multicollinearity, which there might be a little bit between these, so we can look at the multicollinearity here. Oh, there's not much at all. It's just that the variables change. When you include stuff in a model, the variables all start moving around. It's like, imagine like you're in a room and someone comes in, everyone sort of shifts around and like starts talking to people and like, oh, someone just walked in and well, now we're going to like move here. And then someone leaves the room and everyone kind of moves around a little bit more. So when variables enter into the room, it impacts what the other variables do with the model because they're all trying to like do what they're going to do to the model. But with new variables in the model, it changes what the other variables are doing. So there's really no multicollinearity between effective average temperature and weather because of the small VIFs. So it's really not an issue with that. It's just that variables included with the model can drastically change how the variables work in the model. I think that's got it. Really great office hours. I'm so glad we did 474 to start. Then we did 201. Then we did 320. So if you're tuning in, review the video. Lots of great stuff in here for all classes. With that, let's end with a little Saved by the Bun. I'll see 201 very soon. Bye for now, everyone. Bye.